Hello students, welcome to Deeksha Online Mathematics. Let us discuss some problems in areas and differential equations. The area between the curves y equals to 2x power 4 minus x square, x-axis and the ordinates of two minima of the curves. So if you observe carefully this symmetric about y-axis, and if you take common y equals to x square into 2x square minus 1 by observing curve meets x-axis at plus or minus 1 by root 2 and touches at origin, and if you do the derivative, it is 4 2s are 8 dy by dx, 8x cube minus 2x. Even if it equate to 0, there also you are getting 3 points where f dash x is equal to 0. So 2x is common, 4x square minus 1. So x will be 0, x will be plus or minus 1 by 2. So if you find double derivative and find at 0, and what is the double derivative? D square by dx square, 24x square minus 2. So at 0 it is negative, at plus or minus 1 by 2 it is positive. So by observing all these points, we can draw the graph of the curve like this. Symmetric about y-axis, meeting x-axis, touching x-axis, local minima, local maxima, local minimas, two local minimas, and one local maxima. So points of minima, this x equals to minus half to x equal to half. But the graph is below x-axis, and the area you have to do modulus, and the x-axis and the curve and the ordinates of two maximum. So this is the area I am asking. As it is symmetric, required area will be equals to 2 times integral 0 to 1 by 2. So the function with respect to x-axis we are doing so 2x power 4 minus x square, but since it is down, we can use modulus dx. So solve it. You will get the required area. Next problem. The area of the region enclosed by the curve 5x square plus 6x square plus 2y square plus 7x plus 6y plus 6 equals to 0. So if you observe this curve, and let us calculate delta with the formula ABC plus 2fgh minus af square minus bg square minus h square, you will get delta not equal to 0. And what is h square value? 9, ab value is 10. So it represents ellipse. So if you observe carefully, you can get the axis equation, or if you express this as 2y square plus 6 times 1 plus x into y plus 5x square plus 7x plus 6. So I wrote it as a quadratic equation in y. So y equals to minus b so minus 6 into 1 plus r minus 1 plus x plus r minus root of b square means 36 into 1 plus x whole square minus 4 to the 8, 5x square plus 7x plus 6 by 2 to the 4. Now if we expand this and the under root, the discriminant, like 36 plus 36x square plus 72x 40x square, like that, if you simplify that and take 2 common, so minus 3 times 1 plus x plus r minus under root of. So here you can take 4 common, 2 outside, the 2 I cancel. So from the remaining, and if you factorize, you will get 3 minus x into x minus 1. You can check it by 2. So very clearly you will get a restriction for x. And the ellipse will be, you can find its center by doing partial derivative with respect to x equal to 0, partial derivative with respect to y equal to 0. You will get ellipse is a rotated ellipse in 4th quadrant. So x equals to 1, x equal to 3. Now what I have to do, because it's below x-axis, I have to use modulus, and at the same time, if you integrate, now this whole graph is not a function. The whole graph is not a function. That's why this plus part and minus part. So one will be plus part, one will be minus part. And it is symmetric about this line. So any one function, either plus part or y part, you take on 1 to 3, and this y dx, you take either plus part or y minus part. See this plus part and minus part, any one you take the modulus, 2 times of that will be the required area. You will get answer as pi by 2. See, try to understand here. Y equal to, in terms of x you write to get the region for x, means conditions for x. It's your wish. Why I developed y in terms of x? Because I want to find the area with respect to x, so that I want to use y dx form. Suppose if you want to write in terms of x as a quadratic in x, you will get a condition for y. Then with respect to y-axis means x dy you have to do. But in both the ways you will get the same result. Okay, here this finding ellipse and all those things just to know the graph. What is the graph? But the real process lies here. Next problem. The area of the region bounded by the curves y equals to x square, y equal to mod 2 minus x square, and y equal to 2, which lies on the right of x equals to 1 line. Okay. So y equals to x square, you know, this y equal to minus x square. So if you observe, actually y equals to minus x square will be like this. Then this y equal to minus x square, I want to do y minus 2 equal to minus x square. So it will go like this. For that I want modulus. So I will remove these parts and I'll draw upward. So this is the graph of y equal to mod 2 minus x square. Then y equals to x square will be this. Then y equals 2 will be this. So to the right side of 1 means there those two are intersecting. That I think x equal to 1. So 1 to this point will be root 2. If you solve those two, you will get root 2. These two curves you solve, you will get root 2. Then required area will be 1 to root 2. X square minus 2 minus x square dx. Then root 2 to 2. 4 minus x square. Okay, so this transformations, then graph, and right side of the line x equals to 1 means, so if you want me to put in one graph, so this is the graph. So this is the area I want. So this part is y equals to x square. This part is y equal to mod of 2 minus x square. And the line y equals to 2. This is y equals to 2. And the right side of x equals to 1. So 1 to root 2. Root 2 to 2. The next problem. The area of the region included between the regions satisfying minimum of mod x comma mod y greater than or equals to 1 and x square plus y square less than or equals to 5. So you know that this is circle and minimum of mod x comma mod y greater than or equals to 1. So if you take y equals to minus 1, y equals to 1, x equal to minus 1, x equal to minus 1 plus 1, then these points will be 1 comma 1, this will be some 1 comma 2 or 2 comma 1, because the line is y equal to 1, so this will be some 2 comma 1, let us assume. I think 2 comma 1 lies on the circle. So if you draw the part of the circle in this like this, so I am asking the, because mod x mod y minimum is greater than or equals to 1, so these are the regions, this is the dotted area I want. So please observe, this is a circle. So this is x equals to 1 to x equals to 2. So 1 to 2, and if you convert that as a function 5 minus x square minus, so this way we will get this circle area with respect to x-axis minus 1 dx, because this is, that line is y equals to 1, so minus 1 dx if I do, and 4 times if I do that, I'll get the area. So observe carefully, minimum of mod x comma mod y greater than or equals to 1 means, so first you draw x equal to 1, x equal to minus 1, y equals to 1, y equals to minus 1, greater than or equals to 1 regions. After that, see, greater than or equals to 1 means this region will be extended towards infinity, but I want x square plus y square less than or equals to 5, so inside that circle I want. So they are symmetric, so one region area I am finding, 4 times if I do, I will get the required area. Next problem. The area enclosed by the curve mod y equals sin 2x when x belongs to closed interval 0 comma 2 pi. So you know that sin 2x period will be 2 pi by 2, that is pi. So at x equals to pi by 2 only, again it cuts x-axis. So this is pi by 2. This is pi. 3 pi by 2. So this is 2 pi. So this is the graph of sine 2x. Now when we use mod y, means sine 2x must be always positive and y can be both positive and negative. So you should know by transformations, we should remove this part of the graph because it is sine 2x negative, and y can be positive or negative. So since mod y came, no, so this upper parts image you will get, this part image you will get. So ultimately the graph of the function will be like this, 0 to pi by 2, then again from pi to 3 pi by 2. So I think all regions are equal area. So one function you have to take. See, this entire graph is not a function. So this only one part if I take, which is a part of sine 2x only. From 0 to pi by 2 if I do 4 times, I will get required area. I will get the required area. Next problem, the area bounded by the curves y equal to cos x minus cos square x and y equal to x square and x square minus pi square by 4. Observe carefully, this is a quadratic in cos x and this is a quadratic in x square I can take. This first quadratic in cos x meets at origin and pi by 2 and minus pi by 2 also. This meets at x equal to 0, at x equal to pi by 4, pi by 2 or minus pi by 2 also it meets. So by the symmetricity, because cos x is even function, here also x powers are all even. So if you draw the graph of cos x, it will, that quadratic in cos x will be like this. And the other one it will be like this. So this is the required area. So this is cos graph, this is second graph. So from 0 to pi by 2, and since this region and this region are symmetric, I can go for 2 times. So required area will be 2 times 0 to pi by 2. So what is up above curve? Above curve is what? Cos x minus cos square x dx. Now this below curve is second graph, but it is below, no? So I'll take minus integral of same 0 to pi by 2 x square into x square minus pi square by 4 dx. I'll get required area. Observation is very, very important. Quadratic in cos, quadratic in x square, where they are meeting x-axis, are the symmetric about y-axis. By observing, draw the graph, you can solve the problem. So next problem, let f of x equals to x square, g of x equals to cos x, and alpha comma beta, alpha less than beta be the roots of the equation. So some equation is given here. 18x square minus 9 pi x plus pi square equals 0. Then the area bounded by the curves y equals to f circle g of x, and the ordinates x equals to alpha, x equals to beta. I think this factorization is very simple. 6 3 is 18, 6 plus 3 9. So I think x equal to pi by 6 and pi by 3. So let us take smaller one, alpha beta. Then what is f circle g of x? F of g of x. Very simple question this is. So f of g of x. So it is cos square x. F of cos x, which is cos square x. So cos square graph between pi by 6 and pi by 3. So this area I want. So required area is pi by 6 to pi by 3 cos square x dx. That's all. Next problem. The area in the first quadrant bounded by step x plus step y equal to n, where n belongs to natural numbers and y equals to I. Those are the horizontal lines. The I is a natural number less than or equal to n plus 1. Means whatever value n takes, according to that, y equal to I will be selected. Now, if you draw the graph, because it is in the first quadrant only, so this will be x equal to 1, x equals to 2, so on x equal to n, x equal to n plus 1. Similarly, y equal to 1, y equal to 2, so on, y equal to n, y equal to n plus 1. Now if you observe carefully, I can write step x equals to n minus step y. Suppose if I take y equal to 0, then you will get step x equal to n. When you will get step x equal to n? When x belongs to closed n to open n plus 1. Open n plus 1. So when y equal to 0, you are getting x values from closed n to n plus 1. Closed n to n plus 1. So similarly, you go on taking y equal to 1. Then step x will be n minus 1. Then x will be closed n minus 1. Y equal to 0 n to n plus 1. No? When y equal to 1, I think it should be closed n minus 1 and open n minus 2. So on. Suppose if I give the last value for y as n, then step x will be 0, which says that x should be from closed 0 to open 1. Then if you observe carefully, you will get small squares. So we did dash dash, no? So if you do any consecutive like this, you will get this type of squares. So how many squares you will be having? Each square side is 1. So area of each square is 1 square unit. Such squares are n plus 1. So required area will be n plus 1 into 1, that is n plus 1 square units. Next problem. The differential equation for all conics whose center lies at origin. So what is the equation of all conics whose center is at x-axis? The general equation is ax square plus 2hxy plus by square equal to 1. Then I want to get the differential equation for this family of conics. So there are 1, 2, 3. 3 arbitrary constants are there. So first, if I start differentiating and take the 2 common and if I simplify, I'll get ax plus h into y plus xy1 plus byy1 equal to 0. So multiply this equation with x, what you will get? Ax square plus hx into y plus xy1 plus bxy b y x y1 equal to 0. So let us say this is first equation, this is 1, no? So this is first equation, this is second equation. Then subtract 1 into 1 from 2 or from 1, anything. So x square gets cancelled, no? So you will get h into xy minus x square y1 plus b into y square minus xy y1 equal to 1. So I did 1 minus 2. Then if you rearrange, you will get y common. So hx plus by into y minus xy1. If you take common xy1, so you will get hx plus by equal to 1. So this hx plus by you can write as take it common, and I think directly you can write as 1 by y minus xy1. Then now again you differentiate. So h plus by1 equal to minus y1 minus xy2 minus y1 by y minus xy1 whole square. So y1 gets cancelled. Now you will get minus xy2, you will get. You multiply x to this. After multiplying x to this, and you got one equation here, no? This equation, say third. And for this equation, you multiply x. From third and this equation, if you subtract, because I want to make here hx, so I want to multiply x to this equation. And from third equation, I want to subtract so that I can cancel hx. Then I'll get, see this equation, I'm telling again, I am multiplying x. So b will be common, y minus xy1 you will get. Already here you have y minus xy1 whole square. So that b will be equal to, so what you got here, y minus xy1 minus x square y2 by y minus xy1 whole cube. So b will be y minus xy1 minus x square y2 by y minus xy1 whole cube. Now if you differentiate this, because you have only one parameter b, it will become 0. Then you differentiate this, that will be the required differential equation. So please observe, I selected this problem so that I want to show you how I am trying to eliminate ABC. Generally what we will do, the given equation is 1, then one derivative, second derivative, third derivative. 3 derivatives you will do. See, in the last step also you will get y3 after the last step. But how I am proceeding to continuously to eliminate AHB continuously. So first of all, if you take the equation, first derivative equation, second derivative, third derivative, putting all those 4 and trying to eliminate 3 variables will become somewhat difficult. So the way I am proceeding, please observe, that is my aim of this problem. Next problem, find the solution of that differential equation e power x times y square minus 1 by y into xy square dy plus y cube dx plus y dx minus x dy equal to 0. So while discussing the concepts, I told you observation of the problem is very, very important. So if you simplify this equation as e power xy divided by e power x by y, because it is into, no, So if you x into y square by y, y gets cancelled, xy minus x by y into here. If you take y square common, x dy plus y dx plus y dx minus x dy equal to 0. So I can write e power xy, and if I divide with this y square, so I am cancelling y square, I am writing y square here. Then by exact differential equation I can write this is d of xy. So x dy plus y dx, this part d of xy. So e power xy into d of xy plus, I am taking LCM, e power x by y I will get, and this is nothing but y dx minus x divided by y square, no? So it is d of x by y equal to 0. Now observe this step carefully. E power xy into d of xy can be written as d of e power xy, and this is d of e power x by y equal to 0. Now if you integrate on both sides, you will get e power xy plus e power x by y equal to some constant. So observation is very, very important. Next problem. 5 mice in a stable population of 500 are intentionally infected. The context this is to test a theory of epidemic spread that postulates the rate of change in infected population is proportional to the product of the number of mice who have the disease with the number that are disease free. Assuming that the theory is correct, how long it will take to halve the population? So suppose if I take n of t is the number of mice with the disease at time t, can I say n of 0 means at starting 5 mice stable population are infected. So purposefully we started infecting 5 mice. Overall population is 500. So in n, the rate of change, that is the rate of change in infected population, is proportional to product of mice with disease and without disease. So some k. So this is the differential equation we have to produce. Then this dn by n into 500 minus n equal to k dt. So integrating left side by partial fractions you do, and to get the integration constant t equal to 0. So what you will get here by doing partial fractions is it 1 by 500 into integration of 1 by n plus 1 by 500 minus n dn equal to kt plus some integration constant. So simplify this further, and for t equal to 0, what is the n value? You have to substitute 5, so that you will get c value. After that, substituting c, you put n equal to 250, get the value of t, because they are asking what is the value of t to take half the population. So population is 500, no? So after calculating c, reconstruct the equation again, then put n equal to 250, get the value of t. So I hope further you can solve, because it is very easy. Next problem. Find a curve for which the area of the triangle formed by the x-axis, tangent drawn at any point on the curve, and the radius vector of the point of tangency is a constant equal to a square. Okay. Now let us take capital X, capital Y as the equations. Then some arbitrary point px comma y. So if you draw tangent and the radius vector of the point of tangency is this, passing through origin, I am asking the area of this. So this area I can calculate. This is x and the height will be small y. So area of the triangle is half mod x into small y equal to a square. Then what is the equation of tangent actually? Y minus y1 equal to dy by dx into x minus x1. So how to get capital X value? So by substituting capital Y equal to 0, you will get capital X value. So small y into what is the capital X value? Put capital Y equal to 0 and cross multiply, you will get. So y into x minus y dx by dy, dx by dy equal to a square. Then xy minus y square dx by dy equal to plus or minus 2a square. So what you can write this? Dx by dy minus x by y equal to plus or minus 2a square by y square. I think this is a linear differential equation x where p will be minus 1 by y and q is plus or minus 2a square by y. So get the integrating factor and solve it. Next problem. Find the orthogonal trajectory of the circles. Okay, some family. Circles x square plus y square minus ay equal to 0. So if you differentiate and write, you will get a equal to 2 times x plus y by 1 by y1. 2 times x plus y1 by y1. So substitute this a in the given equation. Then you will get x square plus y square minus x square plus y square minus 2 times x plus y by 1 by y1 into this y equal to 0. So in the place of a I substitute. Then if you simplify x square y1 so what you will get if you simplify y square y1? So if I take y1 common, I will get x square minus y square here and 2xy. So y1 cross multiplied and I will get 0. Then what I have to do? To get the orthogonal trajectory, so y1 is nothing but what? Dy by dx. So you have to replace dy by dx with minus dx by dy. So minus dx by dy into x square minus y square minus 2xy equal to 0. Then you rearrange the terms. So 2xy dy minus into minus plus that side if it goes. So to minus y square dx minus into minus plus. So I took minus common, no? So equal to what you are getting? Minus x square dx you are getting. So if you divide with x square, so if you divide this equation with x square, 2xy dy minus y square dx by x square equal to minus dx we got. Then if you observe carefully, exact differential equation is there on the left side. D of y square by x. See, is it x into 2y dy minus y square dx equal to minus dx. So integrating on both sides, you will get y square by x equal to minus x plus some c. So minus x square means you will get x square plus y square equal to cx. So x square plus y square equal to cx will be the orthogonal trajectory for the given family of circles. Next problem. Solve sin y into dy by dx equal to cos y into 1 minus x cos y. So if I write this as sin y dy by dx, I think it's looking like Bernoulli. So we should convert into linear differential equation. So minus cos y minus x cos square y. Okay. Now let us divide with cos square y on both sides. So secant y tan y, sin y by cos square y tan y secant y dy by dx equal to secant y minus x. So if I substitute secant y equals some t, you will get secant y tan y dy by dx equal to dt by dx. So I'm differentiating secant y equal to with respect to x on both sides. So I'll get this as dt by dx equal to, this is t minus x. So can we write this as dt by dx plus minus 1 into t equal to minus x. So observe carefully what we got. Dt by dx minus t equal to minus x. So it is, since dt by dx it is t, then take this as function p and this is function q. This is linear differential equation. No? Integrating factor e to the power of integral p dx, multiply it on both sides, product rule, exact differential equation form, or directly I told you, you can remember as a formula. Okay, thank you very much.